Hi there, everyone, and welcome to the first of a handful of video walkthroughs on your practice midterm short answer questions. What we'll be doing here, again, is just question one. We'll work through it. I'll post a series of other videos as we go through them. Okay, so let's dive into it. So the first question that we have here is a rugby player rushes down the field 27 meters straight down the fields, straight down the playing field in 3.2 seconds before getting into a scrum. Scrum is just when all the players get into that little bit of a circle and are around the ball, fighting for the ball. And that scrum, it moves, so it pushed him back up the field 5 meters over 5 seconds. He breaks free from the scrum, and then with the ball sprints away and scores a try, which is like scoring points, 42 meters down the field in 3.8 seconds. Calculate the average velocity for each of the intervals, which means each of the intervals are segments of this activity, as well as the whole activity overall. We want to try to figure out what the entire motion's average velocity is. Okay, great. So first thing that's always helpful to do is draw a picture, especially when there's lots of different segments going on here. So first up, what I'm going to do is draw my little schematic. So I have my first segment, and again, when dealing with displacement or anything in physics, you want to make sure you're clear on your coordinate system. So I'm going to start at this point, and I'm going to say straight down the field is in this positive direction here. I'm going to determine that that's positive, so that's the first one. It's positive over here, negative that way. So from there, I know that took 27, or that went 27 meters, and the time for that is 3.2. Okay. Then the next part has him moving back this way about 5 meters, and I know that took him 5 seconds. Okay. Then once that scrum was done, end up moving forward or downfield again, so positive direction on the coordinate system, 42 meters, and that took 3.8 seconds. Okay, so let's go back to what the question is asking. It's average velocity for each of the intervals. So we'll just look at part A first. Okay, so there's two ways we can look at this, and when we're thinking about average velocity or any terms that we have, we can always go back to our formulaic definitions of what they are and start getting a better understanding that way. So if we go to our equation sheet, we can take a little look here that if we're looking for velocity, we can see pretty early on, okay, you're actually given velocity for one of these. Now this equation here, the third one, is just a rearrangement of this equation. We can just look at velocity, it's a fairly common one that we have, equals the change in our displacement over time. Okay, so it's asking for average velocity. And so we can look at this equation and, how do we know this is the right one? Well, we're given displacement, so some sort of change of distance in a specific direction. So that's definitely a displacement we can use. And we know it's linear, so there's no curves. It's not a curved distance, so there's not lots of just magnitude of a variable, so that means it's not going to be distance. So we have this set up. We're feeling pretty good because we're also given time. So we know that we have both of those variables. So this is great. So we can start figuring out how we want to solve this. So if we need to do it for each interval, we're going to apply this first equation here to each of the segments that he ran. So we can potentially even just call this segment 1, segment 2, segment 3. Okay. So for number 1, our change in displacement is 27 meters. So velocity equals 27 meters. And then our time segment for that is 3.2. Okay. So all I do in my calculator is I go 27 divided by 3.2, and that equals, and that will equal 8.4 meters per second. So just to pause and kind of review that for a moment. We literally right here in our definition have our units of meters over seconds. Okay, that's exactly what this is here. It's exactly what this is here. Okay, so they're just kind of written at different angles, right? So you have this is the exact same as that. Okay, so if you hadn't really seen that or wondering what was going on when we got to that part, that's an explanation of that. Okay, so that was number 1. We do the same thing with number 2. Okay, but we notice here that it's in a reverse direction, so that's just something to be mindful of. So where do we put this negative? Well, in our coordinate system, it's coming back and it refers to the distance. Okay, so we go velocity equals a negative 5 meters over. Now time generally just moves forward, right? If you think about time, your 5 minutes passes on your watch, 10 minutes passes on your watch. It's always in a forward direction, this change of time, right? So we'll keep this positive. Time keeps running forward, right? So we're going to say 5 seconds. And when we put that into the calculator, what we get is a negative 1 meter per second. Okay, so you'll want to just be mindful of that when you're talking about velocity, in particular a question like this. Okay, great. Okay, so number 3, let's do that up over here. We got, again, just still using the same equation from over there. Velocity equals the change in distance over time, just to rewrite it for you there. So for segment number 3, that means we have 42 meters over 3.8 seconds. Okay. When we plug that into the calculator, 42 divided by 38, we have 11.1 meters per second. Okay, so there we go. That was number A for each of those. Okay. So we can move onward now to part B. So for the entire motion, so from, let's use a different color. So from this point all the way through to here, all the way back this way, and then all the way to here. So from our start to our finish point, it's wondering what is our average velocity. Okay, so from here, what we'll do is we're still working with the same idea, the same principle, the same definition, the same equation here. We just do for the whole motion. Now, one thing that you want to be careful of that you can't do is just take each of these answers that we came up with and find an average. You can't say 8.4 plus a negative 1 plus 11.1 divided by 3. So even though it says average velocity, we can't do that. And one of the main reasons for that is we have this negative displacement, but the time is still positive. Okay, so let's take a look at what that means when we write this out. So let's go good old purple. So let's look at B. Same equation, V equals, but we'll put each of the displacements in as they are. So 27 meters for the first segment, a -5 meters for the second segment, and then we have a +42 for the third. Okay, great. Now again, coming back to that concept of time always running forward, what we do is we take our 3.2 seconds, but time, these 5 seconds here for segment 2, is positive. Okay, it's not a negative factor, right? So it's a positive 5 seconds. Again, time keeps running forward. And then number 3, we go plus 11.1. Okay, or sorry, we got to get the time in there, so that's 3.8. Okay, good. So now from there, we can calculate it through as we normally would. So to be stepwise, we add together all of these terms. So 27 minus 5 plus 42. What we get is 64. And again, this would be all in meters. That's our meters variable. And on the bottom, once we add up 3.2, 5, and 3.8, what we get is 12, and that's in seconds. And now this should look really familiar, quite easy to deal with. When you divide 64 over 12, what we get is 3.5 meters. And to be really complete, we'd say in the forward direction, right? Because again, we stipulated that positive coincided with a positive direction. If you would have put forward, that's fine. If you would have put straight down and then the negative would have been straight up, that would have been fine as well. Or straight down. Okay, and that's it for that question.